Good morning. Today we are on our day 3 notes, which will be all about solving quadratics using the quadratic formula. Up until today, we had no B term. When we don't have a B term, when this B term does not exist, we can solve by square roots. When we have a B term present, that is when we'll talk about using quadratic formula. So the reason I put this up before we even talk about our notes is that sometimes once we get into quadratic formula, people will try to use it for everything. But you really need to keep in mind what we've been doing these last 2 days. If there is no B term present, that solving by square roots will always be our first tool in the toolbox. So let's talk quadratic formula. Use to solve any quadratic in standard form. Set equal to 0. Sometimes, if it's not already set equal to 0, we will have some work to do. We'll leave all answers in radical form as simplified as possible, and that's what we practiced at the end of day 2. That was all of the day 2 homework where we actually practiced how would we simplify that final step. So there's this awesome quadratic formula song. I have no singing ability whatsoever. So I have uploaded 2 videos that sings the song. And maybe one day I'll have the confidence to actually sing with this with you guys, but it actually really does help, okay? So I found 2. This one is to Pop Goes the Weasel, the childhood song. And then there's another one that's a little more modern. So I will play both. If these don't come through on the flipped notes video, you can access them through Google Classroom.
Quadratic formulas negative b plus or minus the square root of b squared minus 4ac all over 2a.
It's pretty awesome, right? It does help. So if you mentally play that a couple times, you will find yourself remembering it. This one is a little bit more of a modern take. And in the process of the video, he actually does go through a proof of where the quadratic formula comes from. YouTube. I can't do it, but this guy's great. So this is the proof of where the quadratic formula comes from.
minus 4ac over 2a. Negative b plus or minus the square root of b squared minus 4ac over 2a.
How awesome, right? So both of these videos will be posted, or actually already are, in Google Classroom. So use them to help you, because it really will help you keep the order. Choose the one that helps you the best, and feel free to blast that out in the shower, you know. Everybody will be so proud. Okay, back to the notes. So we know from our two amazing videos that our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. This formula is what all of today and all of tomorrow will be about. We use this method when a quadratic is not factorable. So again, factoring is still a primary tool if possible, but if factoring is not possible, the quadratic formula will get our solutions every time. The best way to get good at this and to remember how to do this is to practice. So let's start practicing. Example 1, 3x squared plus 5x equals negative 4. Remember, the first step always is to make sure that this is set equal to 0. And when I look, I ask myself, is this set equal to 0? No. And to make that happen, what do we need to pay attention to? Well, right here I see this negative 4. We need to add 4 to both sides. Now notice, there's nothing on the left side that this is like terms with. So this will become 3x squared plus 5x plus 4 equals 0. And if it helps, off to the side, we can actually say what's A, what's B, and what's C. A will be 3, B is 5, and C is 4. Because again, this is coming from ax squared plus bx plus c equals 0. X equals negative b plus or minus the square root of b squared minus 4a c all over 2a. Once we have this set up, we need to be careful with all of our evaluating, because that's all that's left, is using our Algebra 1 skills. So I have negative 5 plus or minus. In your calculators, be very careful. If you choose to enter this, always make sure that this B term is in parentheses, because when and if we have a negative B term, if you do not use parentheses, the whole answer is going to come out wrong. So be very careful with that. But in this case, we don't have a negative, so 25. Always decide on your sign for this next term on your own. I see a negative and 2 positives. So I know that negative times a positive will be a negative. 4 times 3 times 4. Either use mental math, or if you haven't taken out your calculator yet, do that. 4 times 3 times 4 gets us 48, all divided by 6. Simplifying what's underneath the radical, 25 minus 48 is negative 23. We have 3 options when looking at a radical. If I can get my circle the way I want it. Three options, three possibilities. The number stays in, number comes out, or try to break the radical apart. Well, 23 is definitely not a perfect square, so the number is not coming out. 23 also has no perfect square factors, so we can't break it apart, which means the number is going to have to stay in. The only thing we can do, we know that the square root of a -1 is I. So this will become -5 plus or minus I root 23 divided by 6. Applying our skills from last night's homework, I asked myself, are these terms -5, I, and 6 divisible by anything common? The answer is no. This is my final answer. And it means that we have two imaginary solutions because I is involved. Keep in mind that this I came from taking the square root of this -1 under the radical. It does not have anything to do with this plus or minus in between. Let's take a look at example 2. Number 2, 4x squared plus 8x equals x squared plus 35. Remember that we must have equal to 0. To make that happen, we can do two things at once. Knowing where to move x squared, a general strategy we're going to use is always to keep the ax squared terms positive. So if I see that I have a 4x squared on the left and x squared on the right, I know that if I choose to subtract x squared over, I will maintain that positive ax squared value. So that's what we're going to do. We're actually going to move both terms over at the same time. So this entire right side will become the 0 that we need. 4x squared minus x squared, I can do. That's 3x squared plus 8x minus 35. We now have our quadratic set equal to 0, so we can identify A, B, and C. A is 3, B is 8, C is -35. Go ahead and pause the video here and set up the quadratic formula for yourself. Sing the song, whichever version you like in your head. See if I can be brave enough to attempt a partial version of this song. Nope, can't. X equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. The -b will stay. Plus or minus, let's get to simplifying. 8 squared is 64. Observe your signs first. I have two negatives and a positive. So negative times a negative is a positive, times a positive is a positive. Make the judgment call about the signs on your own, and then in the calculator, just do 4 times 3 times 35. And 4 times 3 times 35 should get us 420. All divided by 2 times 3, which is 6. This becomes -8 plus or minus the square root of 484 all divided by 6. Remember your 3 options once we have a radical. The number stays in, number comes out, or we can break it apart. Just to see what we get, let's try the square root of 484 in our calculators. We always want to try that first. Square root of 484, check that out. It comes out to be 22, which means 484 is a perfect square. It's just not one that we're used to. Usually our list does not go that high. So it's always worth it to actually check. Maybe this is a perfect square that we just don't know about yet, or it's not in our general list of known ones. So checking that out, testing it out helps. Now we're down to simplifying. Ask ourselves, is -8, 22, and 6 all divisible by a same value? It is, but I see that I have no radical left. So right away, we're actually just going to break this apart and work towards 2 exact values. So x is going to be either -8 plus 22 divided by 6, or -8 minus 22 all divided by 6. -8 plus 22 is 14 divided by 6. Simplifies to what fraction? 7/3. Or I have -8 minus 22, which is -30. Divided by 6, -5. So here we have 2 real solutions. 2 real solutions. Because we came out to 2 exact answers. So x equals 7/3. And -5. Example 3. Example 3 says -x squared minus 2x equals 2. Remember that we need this equal to 0. Now, technically, if I really wanted to have a positive ax squared value, I could add x squared and 2x over to this side, which makes this side 0, and then we'd be dealing with a positive a value. But for the sake of the notes, I want us to see what it would look like to actually work with a negative a value. So in this one instance, I will subtract 2 to this side. So this will have -x squared minus 2x minus 2 equals 0, where a will be -1, b is -2, and c is -2. We're going to have negatives all over the place. Yay for us. X equals, quadratic formula, -b, in this case, would be a -2 plus or minus the square root of b squared minus 4ac, all divided by 2a. Notice how many sets of parentheses we've used in this setup for good reason. It's really going to help us make sure we don't make mistakes. -2 becomes a +2, plus or minus. This is what I was mentioning before. In your calculator, if you squared this without parentheses, your calculator will tell you -4. So if you choose to enter this entire underneath part in your calculator, no problem. Just word of caution, make sure you use parentheses. Because a -2 all squared is a +4. I have 3 negatives, which I know will produce a negative because negative times negative is a positive, times one more negative is negative. So now 4 times 2 is just 8. All divided by negative 2. This gets 2 plus or minus. What do we now have underneath the radical? Interesting. What's going to be underneath the roots? 4 minus 8 is a negative 4. All divided by negative 2. Using our complex number knowledge, I know that this will be 2 plus or minus 2i. All divided by negative 2. So here's an example. Remember, once we have a radical, 3 options. Number stays in, number comes out, or we break it apart. In this case, it comes out because we can take the square root of negative 4 and get 2i. Last step is to decide, is 2, 2, and negative 2 all divisible by a value? Yes, divisible by 2. But a side note, if we have a negative denominator, we will have a strategy of dividing by a negative. So we're actually going to divide by negative 2. This becomes negative 1 I'm going to put 1 here, and I'll explain why in a second. And then negative 2 divided by negative 2 is 1. So this is negative 1 plus or minus I. The reason why we're just going to say that this is 1, because we have this positive-negative relationship, right? So if I do 2 divided by a negative 2, it's a negative 1. 2 divided by 2, 1. So the positive-negative relationship is still maintained. It's just negative, positive, positive, negative, same thing. In case anybody needs to see what I just said in words, realize that this represents a positive 2i and a negative 2i. So if we divide that by negative 2, this comes out to be negative I, and this comes out to be positive I. So it still maintains positive, negative. And we're done. This means we have 2 imaginary solutions. Now that we have 3 skills examples under our belt, let's work on a real-world question. Number 4. We will be using today starts our discussion about thrown objects. So all of day 1 and 2, we had dropped things. Something is dropped from a height. There is no oomph behind that. There's no velocity. We're now going to have velocity. The throwing object formula is going to be f of x equals negative 16t squared plus v naught t plus h naught. Here's our velocity. Initial height. This concept of h naught was present in our falling objects. And here we have current height. Comes from question being asked. So I'm just going to read one out loud, okay? A powerful crossbow fires a bolt. Oh, as I read, pull out key pieces of information we're going to use for this formula, okay? A powerful crossbow fires a bolt straight upward from a deck 10 feet off the ground with an initial velocity of 320 feet per second. When will the bolt hit the ground? So these are our three key pieces of information given by the scenario. A crossbow is firing an arrow off of a deck 10 feet off the ground. The velocity is 320 feet per second. When does it hit the ground? Velocity comes right out to us, right? Velocity, velocity. The key is determining which is initial and which is the current. The starting point of that arrow is 10 feet off the ground. So if we were to make a list right now, f of x equals, velocity equals, and h naught equals, the starting height of that arrow was 10 feet off the ground, because that's where you started from. The velocity we know is given to us as 320 feet per second. Whenever you are asked ground, that will always be h of t equals 0. Ground is always 0. So now we're ready to set up our formula. 0 equals negative 16t squared plus 320t plus 10. Solving this for t will tell us when we're going to hit the ground. So pause here, please, and set up the quadratic formula. A quick note on why we have negative 16 here. This will always be in terms of feet. That's where negative 16 comes from. It's like a physics connection. So ask your science teacher, you'll learn all about it. It has to do with the gravity on Earth. If this was meters, then negative 16 would change. But these velocity questions, until further notice, will be in feet. So we've got A, B, and C. Quadratic formula, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. That gets us negative 320 plus or minus 320 squared, which is 102,400. I know negative times negative is a positive, so I'll just do 4 times 16 times 10 and get 640, all divided by negative 32. Once we're dealing with real world, we will have decimal answers. So adding 640 and 102,400, we get the square root of 103,040.
Good morning, Eastern High School.
All divided by negative 32. Take the square root and get a decimal.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Students are reminded to be responsible by being on time and in uniform, to be respectful by treating others with kindness, and to be safe with words and actions. Have a day, excellent.
To get ready for SAT, we will always go to 3 decimal places. We're now ready to break this up. So x will be negative 320 plus and minus. I'm going to pause the video here because we are at the end of our class, but online tonight as part of the flipped homework, I will be also showing a technique on the graphing calculator. So be sure to watch the last 3 or 4 minutes and you are all now good to practice. Have a great day. I'll pause it here. I'll keep going to wrap up the last 4 minutes later on today. Hi, everybody. I said at the end of A period that I would rejoin you guys to wrap this example up and then also show you something kind of cool on your graphing calculators. So wrapping up the algebra here, I think I would actually like to just move this over if I can. Hey, check that out. It all moved together. All right. So to wrap this up, we're going to do negative 320 plus 320.998, and that gets us 0.998 divided by negative 32. And here we're going to get a negative answer. So 0.998 divided by 32 gets us negative 0.0312. Again, take it out. Take all decimal answers out to 3 decimal places, please. And now let's do our second answer. So negative 320 minus 320.998 gets us negative 640.998 divided by negative 32. Go ahead and do that in your calculators. We'll get 20.031. Let's reason on what this graph is going to look like. Remember, we really are only interested in our real-world application of this graph. This crossbow is launching that arrow at a starting height of 10 feet. It's going to come up and then come back down to the ground. Launches up and comes back down. When we actually graph this, and we'll see this in the graphing calculator in a second, there is this x-intercept right over here. That will be a negative x-intercept. That is our negative 0.0312. We reject that answer because we cannot have negative time. So our real-world answer will be this second one, 20.031 is when this arrow hits the ground. So 20.031 seconds. We do want to have all of our prior knowledge in mind. So if I ever ask you to say, when does something hit the ground? Remember, ground equals 0, and that will be factoring, if possible. If factoring is not possible, quadratic formula. But we also have at our disposal vertex from prior knowledge. So if I asked you for a maximum height, what's the maximum height of this arrow? You would be back to x equals negative b over 2a, calculating the vertex. Let's just get this one in the graphing calculator first. So let's take out your graphing calculators, make sure it's all cleared out. We're going to type in negative 16x squared plus 320x plus 10. Now remember, this was already set equal to 0 because we had said, when does it hit the ground? So 0 equals this. Enter. When we initially hit graph, clearly this window is not going to work for me. So if we hit zoom, and if you scroll, use your arrows to scroll down, you'll come to something that says zoom fit. From now on, we could actually just hit 0 to get zoom fit, but I already scrolled down to it. So once this is highlighted, I'll hit enter. And it's not really working for me too well. I really am only interested in this real world part of the graph. So if I go to my window, I'm going to change my minimum to a -1. This looked like it was roughly halfway, but we also actually now know when did it hit the ground. Do you remember the real world answer we found? It was 20.031 seconds. So let's change this max value for the x-axis to 22. My minimum y value, if you look now, this is crazy. Let's change that to -1 as well, because we really are only interested in the first quadrant. Hit enter just to double check it's all saved. Let's go back and look at the graph. That's looking pretty nice. So again, remember that even though this looks like 0, we know it's not. If we go back and look at our answers, it's really -0.0312. Clearly on the graphing calculator, it kind of looks like 0, but mathematically we know that's not the case. What if I asked you, when will the arrow be at a height of, let's say, 140 feet? So that would no longer be set equal to 0. That would be 140 equals -16t squared plus 320t plus still the initial height of 10. Before we could set this into the graphing calculator, it needs to be set equal to, I hope everybody is saying 0 right now. So I would subtract 140 from both sides. And we would now get 0 equals -16t squared plus 320t minus 130. This height is going to happen at 2 times. It's going to happen when the arrow is on its way up, and again when the arrow is on its way down. Those 2 answers are going to be roots, because what you're really doing, if you looked at what we did here, we subtracted 140. This now becomes our new 0, so to speak. So we've actually shifted this entire graph down so that our new ground, so to speak, is at 140 and not 0. And I want to show you what that shift looks like in the graphing calculator. So we're not going to calculate it, but I just want to show you that shift and why this will now be called, those 2 solutions would be called our roots. Oops. We're going to put this into the graphing calculator and see what we get. So let's type this into the graphing calculator and see what it looks like. Mentally keep an eye on this. These 2 pieces don't change. -16t squared plus 320t. This is the new part, minus 130. So go back to y equals. Hit your down arrow. We want to leave this graph on the window. So -16x squared plus 320x. But now it's minus 130. Enter. Graph. Notice the visible shift down. So really, I wonder if I can write on this. Nope, I can't. All right, well, let me try. Hey, check that out. Okay, so what we've done with this red second graph that has just appeared, when you solve 0 equals -16t squared plus 320x minus 130 to find, we're answering this question, right? When When is it at a height of 140? You are actually finding these x-intercepts for this red graph. Because what we've done on the blue graph, we have literally taken 140 and shifted this value down to the x-axis, down to the x-axis. So solving this set equal to 0 is finding where these points would be on the x-axis, but again, shifted down. Shift down, shift down. So that's that 0 equals meaning. That's why these will be roots. And we'll keep incorporating these calculator elements in our notes so we can continue to practice. And I will reiterate this conversation about roots tomorrow in class. And that wraps up our notes. Have a great day.